Welcome to Easy Go Life, where we simplify digital success, explore cutting-edge tech, game-changing marketing hacks, and more, crafted to inspire and empower every generation. Let's innovate and thrive together.
Welcome to this React tutorial. In this video, we're going to learn how to build amazing web applications from scratch using React. Now, if you're new to web development, don't worry. I'll walk you through everything step by step in a way that's easy to follow. React is a JavaScript library that helps you create dynamic and interactive user interfaces easily. By the end of this tutorial, you'll have a strong foundation in React and will be ready to start building your own dynamic web applications. We'll cover the basics like setting up your environment, creating components, managing data with props and state, and more. So, grab your laptop, get comfortable, and let's dive into the world of React. I promise it'll be both fun and rewarding. What is React? React is a library created by Facebook to build user interfaces. It allows you to break your UI into small, reusable pieces called components. It was created to solve one major challenge, making web applications faster, more efficient, and easier to maintain. Example: imagine you're building a website with a header, content, and footer. React lets you create a header component, content component, and footer component separately. You can reuse these parts as needed. Key features of React: declarative syntax with JSX. React uses a declarative syntax called JSX, JavaScript XML, which allows you to write what looks like HTML directly inside JavaScript. This makes it easier for developers to describe what the UI should look like based on the application's current state. And React takes care of efficiently updating and rendering just the components that need changes. Example JSX code. Virtual DOM, Document Object Model. React uses a virtual DOM, which is a lightweight copy of the actual DOM. Whenever a component's data changes, React compares the new virtual DOM with the old one and makes minimal updates to the real DOM. This process, called reconciliation, ensures that updates happen efficiently, improving the performance of your application. In traditional web development, modifying the DOM can be slow, especially when multiple elements need to be updated. React's virtual DOM helps avoid this bottleneck by only updating the parts of the page that need changes, making the user experience faster and smoother. Unidirectional data flow. React enforces a unidirectional data flow, meaning data in a React application flows in one direction, from the parent component down to child components. This makes it easier to track how data changes across your app and prevents unexpected behavior. Component lifecycle. Every React component goes through different phases: mounting, updating, and unmounting. React gives you special methods or hooks that allow you to interact with a component during these different phases. For example, you can fetch data from an API when a component first mounts, or clean up resources when it unmounts. React ecosystem. React is not a standalone framework. It's part of a larger ecosystem. You can pair it with other tools and libraries for state management like Redux, routing like React Router, or even styling like styled components. This gives developers the flexibility to choose the right tools for their project. Why use React? Speed. React improves website speed by updating only the parts of the page that change, without needing a full reload. Flexibility. Because it's just a library, React can be integrated with other technologies and tools, giving you the freedom to build the app exactly the way you want. Community. React has a large community, which means there are tons of resources, tutorials, and libraries available to help you build better applications faster. React is particularly powerful when you need to build web applications that are interactive and responsive, ensuring users have a smooth experience across different devices. By using React, you'll be able to develop web apps faster, write cleaner code, and ensure your projects are easier to maintain and scale. In this tutorial, we're going to set up a React application using Create React App and Visual Studio Code. This process is quick and straightforward, so let's get started. Before we dive into setting up our React app, make sure you have Node.js and NPM installed on your computer. Node.js includes NPM, which is essential for managing packages. To install Node.js, head over to nodejs.org. You'll see two download options: the LTS, long-term support, version, and the current version. I recommend choosing the LTS version as it's more stable and widely used. Click the download button and the installer file will begin downloading. Open the installer. Follow the installation instructions in the setup wizard. It's straightforward. Just click Next, accept the license agreement, and click Install. When the installation is complete, you'll have both Node.js and npm installed on your machine. To check if you have them installed, open your terminal or command prompt and run these commands. You should see version numbers for both. If not, head over to the Node.js website to download and install it. Once you've got Node.js and npm installed, open Visual Studio Code. If you don't have it yet, you can download it from Visual Studio Code's website. In VS Code, we'll be using the integrated terminal to set up our React app. With your terminal open in VS Code, let's create our React application. Type the following command and hit enter. Replace My First App with whatever you want to name your project. This command sets up a new React app with all the necessary files and dependencies. Once the setup is complete, navigate into your new project folder by typing command. This changes your directory to the project folder you just created. Now it's time to start the development server and see our React app in action. Type the following command. This will launch the development server and open your new React app in the default web browser. You should see a page with a React logo and some welcome text. Let's take a quick look at the project structure. In VS Code, open the src folder. You'll find the app.js file, which is where we'll be writing our React components. Here, you'll see a simple React component. This is a great starting point for building your app. Now that we've set up our React project, let's talk about something unique to React called JSX. If you've worked with HTML before, JSX will look familiar, but there's more to it than meets the eye. JSX stands for JavaScript XML, and it allows us to write HTML-like syntax inside our JavaScript code. But even though it looks like HTML, it's actually JavaScript under the hood. Let's take a look at a simple example. Here's a basic React component using JSX to render some text. You can see we're using an h1 element just like in HTML, but this is actually JavaScript. React compiles this JSX into regular JavaScript behind the scenes so it can be understood by the browser. Now, let's dive into an example of JSX inside a React component. Here's how we can create a simple component that renders text on the screen. In this function, we're returning what looks like an h1 element. But this is not regular HTML. This is JSX. JSX allows us to write what looks like HTML, but it's actually JavaScript behind the scenes. Now that we've created our first name of the component, let's go ahead and use it in our main app. I'm going to switch to app.js and import the first component. By importing the first component, we can now use it inside our app component. Here, inside our app component, I'm calling the first component as /. This looks like an HTML tag, but it's actually JSX. This makes it simple to reuse components across our app. When the browser runs our app, React transforms this JSX into actual JavaScript functions that render the components on the page. Now that we've set everything up, let's run the app to see our component in action. Once the server starts, it automatically opens our React app in the browser, and there it is. Welcome to React is displayed on the page. So that's how JSX works in React. Another cool feature of JSX is that you can embed JavaScript expressions directly inside your JSX code using curly braces. For example, if you wanted to include a dynamic value, you can do something like this. In this example, name is a JavaScript variable and it's dynamically inserted into the JSX. So, if name changes, the output will update accordingly. Now that we've set up our React environment and explored JSX, let's take the next step by creating our first React component. Components are the fundamental building blocks of any React application. Each component is like a small, reusable piece of UI that you can build and manage separately. Let's start by creating a simple component that displays a message. I'll create a file called greeting.jsx in the src/folder. In this file, we'll define a functional component named greeting. Here's how it looks. As you can see, this component is just a JavaScript function that returns some JSX. The greeting component will return an H2 element that says, "Hi there, I'm a React component." Simple, right? Now that we have our greeting component, we can import and use it in our main app.js file. React components are reusable, so we can use them as many times as we need. In app.js, we'll import the greeting component like this. Once imported, we can use the greeting component inside our app component. I'll replace the existing content with this. Your browser should automatically open, and you'll see the message from the greeting component displayed on the page. One of the best parts about React components is that they're reusable. If I want to display the greeting component multiple times, I can just use it wherever I want inside app.js. For example, I can add another greeting right below the first one. Now when I refresh the page, I see the same message twice. React components incredibly flexible. Now that we've built our first component, let's take it a step further by making our components more dynamic using props. Props are short for properties, and they allow us to pass data to components. This makes components flexible and reusable, no matter what data we send in. Let's start by modifying our greeting component to accept props. Instead of hard-coding the greeting message, we'll pass in a name as a prop and display it dynamically. Here's the original greeting component. To accept props, we just add props as a parameter to the function and use props to name inside the JSX like this. Now that we've made greeting accept props, let's pass some data to it from our app.js file. We can pass the name prop like this. Here, we're using the greeting component inside app.js and passing a prop called name. In this case, we're passing the value John to the name prop. When the app loads, you should see a message that says, "Hi John." Now, let's make our app even more dynamic by using the greeting component multiple times with different names. In app.js, I'll add 2 more greeting components, each with a different name. As you can see, props make our components reusable and flexible. Instead of writing separate components for each name, we can use one greeting component and pass in different values for the name prop. This allows us to build more scalable applications. Here, we're passing different values to the name prop for each instance of the greeting component: John, Sarah, and Alex. When we refresh the browser, you'll see each greeting displayed. Now that we've learned about props, let's dive into another fundamental concept in React: state. While props allow us to pass data into components, state is used to manage data within a component. State allows a component to keep track of data that changes over time, and React automatically updates the component whenever the state changes. To start using state, we need to import the useState hook from React. Hooks are special functions that allow us to tap into React features like state management. Here, we're importing useState from React. This hook will allow us to manage the state in our component. Let's create a simple counter component where we can keep track of how many times a button is clicked. To do this, we'll use the useState hook to manage the number of clicks. Here, we're declaring a state variable called count and a function called setCount. The useState 0 function initializes the count with a value of 0. Whenever we want to update the count, we'll use the setCount function. Next, let's return some JSX that displays the current count and adds a button that increments it every time it's clicked. In this JSX, we display the current value of count inside a p tag. Then we have a button with an onClick event. When the button is clicked, it calls setCount and increases the count by 1. Now let's save the file and run our app to see the counter in action. Make sure to add the counter component to your app.js file like this. When the app loads, You'll see a message that says you clicked 0 times and a button that says click me. Let's click the button and watch what happens. As you click the button, the number of clicks is increasing. This is because the state is updating every time the button is clicked, and React re-renders the component with the new state. Every React component goes through a series of phases during its existence, which we call the component lifecycle. Understanding these phases is key to managing side effects, like fetching data or updating the DOM efficiently. React components have 3 main lifecycle phases: mounting, when the component is created and added to the DOM; updating, when something changes in the component, like state or props; and unmounting, when the component is removed from the DOM. Let's start with the mounting phase. This is when a component is created and inserted into the DOM. It happens when the component first appears on the page. Next is the updating phase. This occurs when there's a change in the component state or props, causing React to re-render the component. Whenever new data is received or user interaction happens, the component is updated. Finally, we have the unmounting phase. This happens when a component is removed from the DOM, like when a user navigates away or a part of the UI is no longer needed. In React, we often need to handle side effects, like fetching data from an API, setting up event listeners, or updating the browser's title. This is where the useEffect hook comes in. useEffect allows us to run side effects at different points in the component lifecycle. Let's look at a basic example. Here, we'll use the useEffect hook to run code when the component is first mounted and whenever it updates. First, we import 2 essential hooks from React: useState and useEffect. These hooks allow us to manage state and handle side effects like timers inside functional components. Now, we create a functional component called timer. This is where the main logic for our timer will live. We define a function called timer, which represents the component. Next, we define a piece of state called seconds using the useState hook. Initially, this is set to 0. Every time the timer ticks, this value will increase. Now, we'll use the useEffect hook to set up the timer. Inside the useEffect, we define an interval that runs every 1,000 milliseconds, or 1 second. On each interval, we increase the second state by 1. Inside the useEffect function, we set up a timer using setInterval. The timer updates the second state every second. To prevent memory leaks, we clear the interval when the component unmounts by returning a cleanup function inside the useEffect. We return a cleanup function from useEffect that runs when the component is unmounted or when the effect is rerun. This ensures we don't keep old timers running in the background. we return a cleanup function from useEffect that runs when the component is unmounted or when the effect is rerun. This ensures we don't keep old timers running in the background. Finally, we return a simple p tag that displays the current value of seconds. Every time seconds changes, React will re-render this component, updating the displayed time on the screen. And that's it. We export the timer component, so it can be used in other parts of our app. Now, let's save the file and run our app to see the timer in action. Make sure to add the timer component to your app.js file like this. Let's run the app by typing npm start in the terminal. When the app loads, you'll see that timer gets started, and after refreshing the page, it starts new timer. And that's the life cycle of a React component. Components go through mounting, updating, and unmounting phases, and the useEffect hook helps us manage side effects, like fetching data or setting timers. And that wraps up our React series. Let's take a moment to recap what we've learned. We started from the basics, learning how to set up our React environment, exploring how React components serve as the building blocks of every React application. You also got hands-on with JSX. We moved on to props and covered state management using the useState hook. The React component lifecycle, understanding how components mount, update, and unmount. So by the end of this series, you've built a solid foundation in React. With this knowledge, you're well on your way to building dynamic, responsive, and scalable React applications. I encourage you to experiment, build more projects, and explore advanced React concepts like context, hooks, and routing. Thank you for following along with this React series. I hope you found it helpful and inspiring. Don't forget to like, share, and subscribe if you want to stay updated with more content like this. Happy coding, and see you in the next series.
Thanks for watching. If you enjoyed this video, give us a thumbs up and share it with your friends. For more exciting content on tech, inspiration, and lifestyle, make sure to subscribe and join our community. Got a topic you want us to cover? Drop a comment below and let us know.